Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with Descriptive Econometrics, and in the last lectures we have discussed about this particular component, and specifically we have discussed the issues like central tendency, dispersions, and a kind of spreads of the particular data series or distributions. So, these are all called as basics, and sometimes called as univariate statistics, and that will help a lot to analyze certain problems, and again that is the kind of typical requirement of a hardcore kind of engineering econometrics. So, when we like to solve a complex problem, and this descriptive econometrics, that to the kind of central tendency, dispersions, then spreadness, all these things are very much required. Until unless you know details about the data structure and the kind of variable natures, you may not in a position to pick up a good models to analyze any kind of engineering problems. So, that is how it is a mandatory to know certain things, the basics, that is what we can call as basic statistics or descriptive econometrics, and something called as univariate statistics or univariate econometrics to analyze the kind of data, and that to know something more about the data before we proceed for some kind of complex empirical investigation process. The idea about this particular topic is like this. Since we have already discussed the kind of univariate structures, then slightly we will move into bivariate structures, where we have certain tools through which we like to know the measurement, or we like to know the relationship between two or more variables. In fact, the accurate engineering econometrics will start with more number of variables, maybe at least with 2 variables, or you can say 3 variables or more than 3 variables. But with a single variables, then hardcore econometrics may not be applied. But when we solve a particular engineering problems, we assume that there are various variables which can be used or which can be very helpful to analyze the engineering problem. But in that context, every variables corresponding to the data availability, we need to check independently and through some kind of relationship measurements, and then we will proceed for some kind of hardcore engineering investigations. For instance, in this particular lectures we specifically highlight the bivariate structures like covariance and correlation, and that will add value to the hardcore engineering econometrics. So, the basic idea about this particular lecture is to know the concept of association and its role in analytics or some kind of econometrics, learn to calculate covariance and correlation, to understand the difference between covariance and correlations, and understand the difference between correlation and causation, and then we will solve some of the problems with the help of data, just like we have discussed earlier. So, whether it is a univariate structure or bivariate structure or multivariate structures or whatever may be the kind of problem. So, we have two different setups. The first setup is the input structure, and then the second setup is the output structures corresponding to a particular engineering problem. So, we have a input clusters where variables are identified, named properly, and we must have a data. And then the second stage of process is the engineering econometrics output, and for that these inputs are very essential. Then what we are supposed to do? So, we are supposed to pick up certain engineering econometrics tools, maybe manually you can calculate or through some softwares. So, the idea behind these softwares or the manual process to transfer these inputs to some kind of engineering econometrics output, and for that we have to apply some of the engineering econometrics tools. And It may be univariate structure, it may be bivariate structure, or it may be a multivariate structure, but in this particular lectures we specifically highlighting the basics only. So, that means for any kind of hardcore engineering econometrics problem, so the minimum requirements or the basic need or basic check is the descriptive statistic and the kind of correlation matrix, which we will discuss in this particular lecture. Of course, the descriptive statistic, the kind of central tendency, dispersions and spreadness, all these things are discussed in the last lecture, but in this case we specifically highlight the association structure, because the association structure will take you to a path of hardcore engineering econometrics investigations. So, with the help of data, so we like to know the details about the descriptive statistics, then the correlation statistics, and after that we can proceed for the kind of actual econometrics investigations. So, when we go for actual econometrics investigation, so we must have a clear cut details. So, starting with variables, the I think the data availability, and then the kind of the basic descriptives or univariate statistic corresponding to the each variables, and that to corresponding to this data. So, once we have all these details, then we will think about the particular process, how a beautiful models or how a accurate model can be used or can be applied to analyze the particular engineering problems. So, the starting process of this particular lecture is the covariance issue and correlation issue. So, what is about this correlation and covariance? Let me little bit brief about this. Correlation is not actually something called as causations. It simply represents the association between two variables, and so that means technically when you have a two variables, so we may have association or you may not have association. So, our job is to check whether there is a kind of association or no association. So, again, so when we go for hardcore engineering econometrics investigation, so one of the basic techniques which we frequently use is called as regression modeling, which I have already highlighted very specifically in the first couple of lectures. So, that means the entire engineering econometrics problems more or less connected to a regression modeling. So, here what is our job? You have to just check the basics before you go to the regression modeling. For instance, one of the requirement of regression modeling is the classification of dependent variable and independent variable, and that too when there is a kind of independent variable clusters, there should not be any further relationship among them. So, now that is the requirement of regression modeling, but in reality the things are different. So, there may be a chance that there is a association among these independent variables. So, that is how, so descriptive econometrics will let you know whether you are in correct track or something right way to proceed for the kind of hardcore investigation and the kind of solution for the particular engineering econometrics problem. So, it is simply starts with it starts with a covariance and correlation. Covariance is simply the degree of association between two variables, and that too it is not a unitless measurement technique, while correlation is a unitless measurement technique and it is a standardized component. So, what we like to check here, whether there is a relationship between two variables, it may be independent to independent or independent to dependent. So, technically for covariance and correlation, the issue of dependent and independent is not there at all, but it will give you a kind of path for the regression modeling. So, that is how we need actually the entire correlation matrix with respect to all variables simultaneously. So, it will by default it will give you clear cut pictures before you start the hardcore engineering econometrics investigations. So, now the process is like this, let us say these are all different scores, and we like to know whether these scores are correlated to each other. For instance, So putting money putting money in a particular investment process, that's called as let us say expenditure. And this particular example is related to student scoring, and for instance this is actually student scoring, and then the kind of expenditure invested towards particular students. So then usually the perception is that if you put more money towards students for their preparation or something like that, then obviously they will score well. So theoretically, so there is a link between putting money towards the students and the student performance. So now to justify this particular theoretical evidence, so we like to empirically test, and one of such a technique which you can use is called as association technique, and that too you can either use covariance or you can use correlations. So of course correlation is better technique than covariance, but ultimately the requirement is to check whether there is a association or not. So in fact covariance is actually one of the component in correlations. So just having covariance and divide by a variance of these two variables will give you the correlation coefficient. So ultimately, so there is big difference between correlation and covariance. So what will we do here? So we like to just check how is this particular case, and then we will analyze the requirement. So this is this typical formula through which you can actually calculate. So it's a kind of degree of association between two variables. In the last lecture we have discussed the concept called as standard deviations and variance. So when you are relating one variable with same, means variable to variable, same variable, then it's called as variance, or if you mathematically if you calculate the square root of that variance, then it's called as a standard deviation. So now when you are connecting variable upon same variables, then it's called as a variance. So then variable with different variable, then when you are connecting, then it's called as covariance. So that means technically, so this is x minus x bar into y minus y bar. So when you are actually just having x minus x bar into again x minus x bar, then it's called as a variance, otherwise it's simply called as covariance. So for instance, for two variable, let's say variable 1 and variable 2, so then we can have a kind of matrix. So 1 2 and again 1 2. So that means technically we have actually a two correlation matrix. So this is what actually let's say sigma 1 1, and this is sigma 2 2, and this is sigma 1 2 and sigma 2 1. So that means this is what actually called as variance. If you this is also variance. That means square root of variance is standard deviation. So variable upon variable. So let's say this is x, and this is x, and this is y, and this is y. So x upon x, this is a standard deviations, or called as a variance, and then y upon y, again it's a standard deviation, and that's the variance. And this is a x upon y, and this is y upon x, this is called as covariance. So that is the only difference. So it's kind of variable upon same variable, that's the indication is the variance, and variable with other variable, that's called as covariance. So likewise you can calculate correlation. So correlation is just covariance divided by a square root of variance of both the variables. Then it will give you some kind of weight factor which can describes the detail about the relationship between these two variables. So now corresponding to this yes, there is a population structure and sample structure. In fact we have actually separate lectures to highlight the issue about the sampling. So that times I will clarify what is the big deal between sample and population. So usually most of the empirical process is the sample specific. We just pick up the sample and then test accordingly. Then on the basis of inference and the kind of results from the particular samples, we generalize the particular engineering problems, or we will go for general policy issues or something like that. So, this is how the kind of process. So, this is a plotting, and sometimes give you some kind of idea about whether there is a kind of association or not, but ultimately so we need to quantify it, and covariance correlation is the measurement techniques which can give you a quantitative output that can address that will be better way to address the particular associations. Otherwise graphically showing something else, so you may not actually properly interpret. So because it will not give you some kind of unique kind of quantification, but the beauty of the correlation is it will be ranging from -1 to +1, and if you transfer into percentage form, then it will be actually 0 to 1 both positively and negatively. Correlation can be negative, correlation can be positive, and if correlation coefficient is coming positive, then the variables are positively related to each other, and if a coefficient is now coming negative, then the variables are negatively related to each other. So, so the three specific kind of extremes are -1, 0 and 1. So, when the correlation coefficient is coming -1, so that means technically it represents that there is a strong negative association between the variables, and when you will get +1, then there is a perfect positive relationship between the two, and when we get exactly 0, that means there is no association between the two, and so that means technically in the first instance you have two different classifications. So, no association and association. If no association, the correlation coefficient will be 0, and if it is association, if there is association, then either it will be -1 or 1 or in between -1 to 1, not exactly 0. So, having -1, then perfectly negative representation, having +1 perfectly positive association, and if in between, let us say -0.9 or +0.9, -0.8, something like that. So, that means it is it can indicate that highly correlated or more significant associations, or more considerable association, or if it is close to 0, then it is a less association, something like that. So, that means one way classification is a association, no association, and that too the quantification is a correlation coefficient r equal to 0 and correlation coefficient r not equal to 0. Again, when the means in the case of r not equal to 0, so we have -1, 1, this is one extremes, another is actually you can put actually 0.5, that is the middle, and anything less than 0.5 is called as a less association, and anything above than 0.5 is called as high association, and close to 1 means very high association, and close to 0 means very low associations, may be positive, may be negative. So, it is not a big deals, but our job is to know whether there is a kind of positive association or negative association or no association. Of course, at the research levels or empirical kind of testing, the negative inference or the kind of positive inference have a different kind of policy implication. That is why having just plotting, you may not actually perfectly visualize, or you can just perfectly can guess that there is a positive associations, or there is a strong negative association. That is why there is a need of some kind of quantification. Of course, visualization is a good trick, but sometimes it may not give you a kind of clear cut path to address the problem very perfectly. That is why some kind of quantitative measures we need to use to represent the particular fact in a much better way. So, this is how the particular structure. So, this is how the formula through which you can actually calculate. This is the correlation coefficient formula, and that too between the two variables, and this is the kind of population case, and this is a kind of sample case. Of course, in the first instance you may not confuse the population correlation coefficient, sample correlation coefficient. Just from the beginning, you can start with the structure that you have at least two variables, and corresponding to each variable you have a sample points, and all the sample points must be uniform. That is one of the basic requirement. And if it is actually, that's called as what balanced sampling. If it is unbalanced sampling, then you need to prepare a balanced sampling by removing the other items in a particular variables, or fill up the missing observations of a particular variable. Then finally, you must have a uniform observation corresponding to both the variables, then you are in a position to calculate the correlation coefficient. And this is one of the basic requirement of regression modeling or engineering econometrics. Until unless you know the relationship, you should not start regressing. That means technically, before you start hardcore engineering econometrics investigations by using regression modeling, so you must have theoretical evidence whether there is a kind of association between the two variables, and there is also some kind of statistical evidence whether there is a kind of that means we start with the theoretical evidence and some kind of statistical evidence, and then we will go for in-depth kind of investigations by using regression modeling to know the details about the particular relationship. Who is the cause, who is the effect, and how is the particular relationship, and whether the particular relationship is affected or or to be affected by other variables. So these are the issues which we we usually actually look forward, and that to the requirement of engineering econometrics. We typically give stress on engineering econometrics to solve all these complexity issues. So that is how we need to know the basics first, and then we will go for the kind of hardcore engineering econometrics problem. And then specifically, so this is how the particular structure. So now so this is how the snapshots, so how they are related to each other. And if you could see here, this is a positive correlation because it is going in one direction. This is a negative correlation, it is also going opposite directions. And the process which we are discussing here, there may be two divisions. It is a kind of linear associations, and there is something called as nonlinear association. That means if the kind of plotting between these two variables are going in a kind of one similar kind of directions, maybe positively, maybe negatively, then this is called as linear structure. For instance, the figure 1 and figure 2 is the classic examples, and figure 3, so the plottings or the common points are actually very different, not exactly follow a particular path. As a result, simple declaration is there is no association, and that too we are just detecting through visualization, but still you can use correlation coefficient and get to know. So in this particular case, for instance, in the third case, so this case, so if you apply correlation coefficient, then obviously the value will be close to 0. But in this case, the value will not be 0, but the relationship is coming nonlinear. So that means correlation coefficient can be linear and can be nonlinear. So that means the typical structure is the association is the linear one and the association is the nonlinear one. In other words, the relationship is linear one and the relationship is nonlinear one. So that it depends time to time, situation to situation, problem to problem. So today the two variables are linearly related to each other, simultaneously going, but because of certain other factors influence or something like push factors and pull factors, so they may be related but not in a linear platforms. They will relate each other in a kind of nonlinear platforms. So our major deal is not whether linear or nonlinear. Our major deal is whether there is a association or no association, and whether they are positively linked or negatively linked. Of course, in the case of nonlinearity, so some instance it may be positive association, some instance it is a negative association, which is not there in the case of linear structures. In the linear structures, the straightforward answer is in negative ones or positive one, but in the case of nonlinear, some extent it will be positive and some dimension it may be negative. So that is what the complexity is all about. So that means real life problem will be like that only. So you will not get actually very perfect signal in the first instance. So, that is how we need actually in-depth investigation to find out the actual fact and reality to address the engineering problems as per the particular requirement. And for that, so the engineering econometrics and that to hardcore regression modeling is very essential, without which we are not in a position to find out the perfect kind of requirement for the engineering problem. So, obviously, so this is how the kind of structure, and then ultimately so this is how the Excel spreadsheet, and in the Excel spreadsheet just you pull the kind of structure and you get the results very easily. For instance, let us say this is a Excel spreadsheet, and we will just take few variables. For instance, let me take few data point here. This is big data, and I will take you to new Excel sheet, and then you paste it here. Okay, so this is you will do the pasting here, and just I am just elaborating. And okay, so this is how the variables, and you can say that this is a variable 1 and this is variable 2, and we have 6 data points for x1s, and we have a 6 data point also for x2. So, that means we have a balanced sampling, and for if the first hand requirement is balanced sampling, then we can easily use covariance or correlation. But if the data points are not balanced, so then we will first adjust the balanced balanced data, and that means either you remove the extra points, or you can fill up the missing observations, whatever way you can do, but ultimately we need balanced sampling to do the particular analysis. Ultimately, having these inputs, so we need actually let us say correlation. So, what I have already mentioned, we have a couple of softwares, and in the last unit we specifically highlighted the beauty of the Excel spreadsheet, and within the Excel spreadsheet we have a data analysis package, and then we have actually a Excel start. And Excel start is a very hardcore package which can solve almost all problems of engineering econometrics. But in the meantime, so we are just using simple Excels and to report the kind of correlation. So, that means for that we just put anywhere else equal to signs, and go to this particular functions and find out to report the correlation coefficient. Okay, so what will it do? So, so otherwise you can go to the data, then data analysis package. So, here you will find correlations. Okay, so if you put correlations, okay, so this will be showing that there will be a correlation coefficient. Okay, just click here and you indicate the variable response here and close the loop, and then you just put the enter. Yes, this is coming. So, now so this is how the indication, clear cut indication. So, that means what we have given the indication that we are just putting the correlation formula. So, just you write put equal to signs and give the command about the correlation. So, it will ask you to give the x1 range and x2 range. So, obviously, when we are putting the x1 range and x2 range, so it will check the balance sampling, and then by default it will be processed through the particular formula, and you will get the correlation coefficient. So, this is a simple way to calculate, but in the advanced softwares like Excel start or SPSS, EBUs, microfit, CATs, RATs or Shazams, whatever software you can use. So, you just give the indications that variable 1, variable 2. So, automatically it will read the range and check the balancings, whether it is a balanced data or unbalanced data, then report the correlation coefficient as per the particular requirement. Then ultimately this will give you some kind of some kind of clarity to know whether there is a kind of association or no association. For instance, in this case the value is coming 0.796, that means it is a 80% association. So, what I have already mentioned, so the correlation coefficient will be in between -1 to 1, and in the first instance the division is association and no association. If it is like that, then quantification will be R will be equal to 0 and R not equal to 0. If R not equal to 0, then the game is on. So, here we like to know more about the relationship, whether it is a positive or negative, high or low, something like that. And against there is issue of whatever correlation coefficient you have, negative, positive, whether it is statistically significant or not. Till now we have not started this particular investigation process. We are just reporting the descriptive statistic or bivariate statistics to know the facts about these variables corresponding to the reported data. But ultimately the particular statistic need to be tested again empirically through some process that is called as a inferential econometrics, where we need to connect these statistics with testing procedures. That is what called as a hypothesis testings. So, hypothesis testing again is a kind of step by step process, where the idea about the problem is whatever parameters value or test statistic value which you have received from the particular variables or the particular problems corresponding to the data. So, that need to be checked, and the reporting must be required whether it is empirically valid or statistically valid. That is what we use the term called as statistical significance. So, at the econometrics angles or the level of testing followed by hypothesis testing. So, we take care of the issues like 1%, 5% and 10%, and that means the issue is like that we have to formulate the null hypothesis and the alternative hypothesis with the intention that the particular test statistic is 0 not 0. Then ultimately from the data we will get the test statistic value and it connect with tabulated values. Then we will check whether the calculated value through the data is overtaking the tabulated value with a particular probability level of significance. Econometrically we have to check, or we have to compare with 1%, 5% and 10%. Anything we are rejecting at 1% is always best. If not, then we will come down to 5%, and then we will come down to 10%. And if at the 10% level, if we are not in a position to reject, then the declaration is that yes, there is a correlations, but the correlation coefficient is not strong enough or not statistically significant. So, if something is not statistically significant, then the empirical validations or empirical evidence is not so supportive. So, that is why we try to analyze in such a way. So, we should have some kind of output such that we can empirically have a evidence. And in the first instance you may not have, and that is how the game is all about. So, it is a very interesting game. So, because the things are very continuous and structuring, restructuring, it is the kind of iterative process. Sometimes you can increase the sample size, decrease the sample size, and add variables, remove variables, then means you will continuously do and find out some hint, and as per the particular requirement. The thing is that before you enter to this games, you are theoretically convinced that there is a relationship and there is a logic behind it and there is a theory behind it. So, now once the empirical results are not coming as per the logical evidence or theoretical evidence, so you must be very careful why not coming. So, that is how we have to do the iterative process till you get the particular answer. Even after that you are not getting the answer, then the theory we need to recommend that there is something wrong about this theory and there is something wrong about this particular logic. So, the that is how the challenge part or the kind of complexity part, and where the engineering econometrics rule is actually absolutely highly means you can say high requirement. So, ultimately in this particular lectures we have gone through the particular component called as a covariance and correlations, which can specifically highlight the issues about the relationship between two variables, which is one of the basic requirement of regression modeling, and that to engineering econometrics, and that to address a particular engineering problem. So, whatever we have discussed right now, this is called as a simple correlation structure, and it has also complex issue. and complex issue starts with more number of variables and the significance issues and the kind of regression requirement. All these details will be there. So, we will discuss these details in the next lectures. In the meantime, we will stop here. Thank you very much. Have a nice day.